Okay, so what I'm going to do is I'm going to what's it called? I'm gonna pull this up right here, what I sent you guys. I want this gone. Hide. Okay. Um, let's go announcements to the I lied kind of see you all at 5:10. Okay, and what we're gonna do is we're gonna copy and paste this um into Word, Control C. I'm just gonna go Word, whatever, file, new. Okay, so I do have a practice exam, kind of, but I was looking at this as I was going through and making practice exam questions, and I realized um, it might be really beneficial to give you guys prompts to make your own questions. So that way you are using the exact right prompt to create the perfect question for you guys to practice as many times as you want. But the nice thing about this is it gives you all of the questions, and then at the end, it gives you the answers as well as the what's it called? As well as the explanation. The key to using chat for something like this is ask for as little as humanly possible. Okay, and as long as you ask for as little as humanly possible with as much specificity as possible, you're gonna get a lot better result. So what I'm gonna do is I'm going to go through and we're going to basically do these together. And what you'll see is this is literally just systematically working through the entire exam. And so yeah, like right here, give me a practice exam question with 4 to 6 matching questions that goes along with it, in which you make sure that students differentiate between classical, empirical, and subjective probability using blank as a subject to the question. Now, why am I using blank as a subject to the question? Because not all of y'all care about Hot Wheels. Facts? Okay, so give me something else that you guys care about. Anything.
Baseball.
Baseball. Okay. So I'm gonna come right over here, Control C, and I'm gonna come chat, Control D, using baseball as the subject. Oh, it wants me to log in. Give it a second. Using baseball. Okay. So the Baylor Bears team has won 60 out of 100 games. The league has 10 equally skilled teams. Okay, basically you've got to go through here and say, is this classical, empirical, or subjective probability? Cool, you guys ready? First one, the chance of a batter hitting a home run when each outcome, hit, miss, or walk is equally likely in theory. What is this? Classical, why? Yeah, there's 3 possible outcomes. Every one is equally likely. Based on the season record, 60 wins in 100 games, the probability the team will win their next game is estimated to be 0.6. What is this? Empirical, why? Yeah, based on past. Yeah, it's the number of past successes divided by the total number of past tries. Okay. The coach Ramirez feels that his team has a 40% chance of winning their next game due to the pitcher's injury. What is this? Subject. Okay, why? Because it's based on lots of different information and really not either one of the other two. The probability of rolling a fair die and getting a number 1 to 3 to simulate the team's chance of winning. I hate using dies for whatever, but what is this? Yeah, classical. Using actual historical data of home runs in the last 200 games to estimate players' chance of hitting one today. What is this? Empirical. then sports analysts predict a 25% chance of the team winning a championship because of a strong competitor. Objective. So the nice thing is, dum, 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 gives you your answer key right below. Isn't this great? Do you guys like this so far? Okay. So let's go to the next question. Y'all give me something else besides baseball. Anything besides baseball. Not softball either. Preferably not sports. I'm trying to demonstrate that you guys can do things with this that you actually care about. Hiking, triathlons, Ironman. We just had the Ironman. So give me a practice exam question with 4 to 6 matching questions that go along with it to differentiate, so on and so forth. So it's going to take a minute. Okay, here we go. So we've got 2 events. An athlete competes the full Ironman training program. An athlete finishes the Ironman race successfully. Okay, so what is the probability that an athlete completes the full training program is 0.7. The probability that an athlete finishes the race given that they completed the training program. So in other words, probability of B given A. The probability they complete the race given that they completed the training program is 0.85. The probability an athlete finishes the race completed the training is probability of A and B is probability of A multiplied by the probability of B given A, which is 0.595. So now you've got to ask some questions, match each of the following with the correct probability type. This isn't exactly what I wanted. I wanted you to solve for it. So you can always go in there and change it. Make us solve for the actual probabilities. Okay, but either way, let's look at this. There's prior probability, there's conditional probability, there's joint probability. The probability that a random chosen athlete completed the Ironman training program. Prior. Okay, notice we're looking at 2 possible events. One event is they did the training program. The other event is they did what? They completed the Ironman. Okay, so this right here is what kind of probability? What is it? Prior probability. What is this? The probability that an athlete successfully finishes the Ironman race given that they completed the full training program. Conditional, okay, which the probability that they completed the Ironman race, this little line right here, what does this little line mean? Given that they completed the training program. How we feeling? I'm pretty confident that y'all are probably a little stuck on this one. Is that accurate? Okay. How do I know that? Because I had like 4 people coming to my office today asking about this. Okay, so let's look at another one. The probability that an athlete both completes the training program and successfully finishes the Ironman race. What is this? Yeah, joint conditional probability. So probability of A is they completed the training program. Probability of D, they completed the Ironman given that they completed the training program. So probability of A multiplied by the probability of B given A. So y'all give me another example besides Ironman. Any topic.
Movies.
Movies. Give me something more specific about movies.
Like maybe highest grossing films in like box office this year.
That's the subject of the question, and make students calculate the actual probabilities. Okay. So we have two events. Event A, the movie is a sequel. Event B, the movie earns over $100 million in gross profit. So 80 out of 200 movies were sequels. 50 out of those sequels earned over 100. 60 non-sequels also earned over 100. So what do we got? Coming right down here. Prior probability, the number of sequels divided by the total number of movies. So what's the probability? What is the prior probability of it being a sequel? What is it? Which is the whole is, okay. So the prior probability of it being a sequel is 40%. Okay, what is the conditional probability? Let's come down here. The number of successful sequels divided by the total number of sequels. So we've got 50 did over 100 million. So 50 out of how many? 50 out of 80. So what is the conditional probability? What's 50 divided by 80?
62.5%.
62.5%. Okay. And then the joint probability is what's the probability of it being a sequel and it being successful. So what we're going to do now is 0.4 multiplied by 62.5. Okay. You guys tracking with this a little bit better now? Do you guys see how putting in topics that you actually care about might click with you better? Are we still a little bit leery on this one? We'll see. Okay, if you guys are leery, then I need you guys to give me a topic. But let's look at this. The probability that a randomly selected movie is a sequel. This is the prior probability, is just 80 out of 100. The probability that a movie earns over $100 million given that it's a sequel. So this is where it's screwed up. You guys see this right here? There's this given that symbol right there. It does something to the format, but it's essentially 50 out of 80, so on and so forth. Okay. Questions about this? Okay, so the prior probability is something that, hey, what's the probability of it being a sequel? The conditional probability is what's the probability of it being successful given that it's a sequel? Okay. The joint probability is what's the probability of it being a sequel and the probability of it being successful given that it's a sequel. So the joint conditional probability has this fun little word. What's the fun little word? And. Joint conditional has the word and. Okay. Conditional has the word given that. And then prior doesn't have to have either. How are we feeling about that? Better? You like the keywords? You guys want another topic? Or move on? What's a different topic? Move on. I don't know what this is. Next. Word. You guys are so quiet. Not that. Word. Okay. Give me a joint conditional probability question with 4 to 6 matching questions that goes along with what students must calculate the correct answer for various outcomes question using blank as a subject. So what's the subject? Give me a subject. Hunting. Okay, a wildlife study tracks the success of 200 hunters over a whole full hunting season. The hunter uses a bow instead of event A, the hunter uses a bow. Event B, the hunter successfully harvests a deer. So from the study, 80 hunters used a bow, and then 50 bow hunters harvested a deer, not a deer. They probably, anyway. 90 of the rifle hunters harvested a deer. And so from here, you can go through, and, look at the prior probability of A, they used a, so this is one of those things where, uh, event A, coming right down here, the probability that they used a bow is going to be 80 out of 200, which they use like the same numbers. And so you can kind of go through, down through these, and then it gives you the answer key as well, and it shows you, hey, this is exactly how it's done. Okay, this is one of those things where it's really easy to get lost in the weeds. So take it as at face value as you can. Let's do one that's a little bit easier. Sound good? So let's use golf. You guys want to use golf? I like golf. Actually, I'm horrible at golf. So I hit a ball. I either hit a good shot or a bad shot. Okay. If I hit a bad shot, the probability of my next shot being a good shot goes down. Facts? Okay. So my first shot, I hit a good shot. The probability of me hitting a good shot on my first shot is 70%. What's the probability of me hitting a bad shot? 30%. So 70% is the probability of me hitting a good shot. Okay? The probability of me hitting a bad shot is 30%. If I hit a good shot, the probability of my second shot being a good shot is 60%, which means that the probability of my second shot being a bad shot is, what is it? 40%. Okay. Well, what's the probability of my first and second shot being good shots? 42%. How do you get that?
30%.
There you go. The probability of hitting my first shot a good shot was 70%. The probability of hitting my second shot a good shot was 60%. The probability of me hitting the first and the second is just 0.7 times 0.6. How we feel? Good? You guys like the golf example? Okay. Let's go on to the next one. Word. You can do golf again. Okay, so we're at a golf tournament. What's the probability that Ava sinks a birdie on the hole? It is 30%. The probability that Ben sinks a birdie on the same hole is 25%. So, what's the probability that they both make a birdie? What's the probability that at least one does not, one makes a birdie? What's the probability that Ava does not make a birdie? What's the probability that they both miss the birdie? Okay, and then there's all of these notations right here. You guys know what a birdie is? Birdie is when, so par, so say you're supposed to hit it in three. Instead of hitting it in three, you hit it in two. Something that I've rarely seen in my life. I'm just not good. Okay, so looking at this, what's the probability that Ava makes a birdie? %. What is that called? What is it? Yeah, prior probability. Okay. What's the probability that Ben makes the birdie? 45%, and that's still prior probability. Okay, now this is where we have those circles, right? The probability of Ava making a birdie has a circle of 30%. The probability of Ben having a birdie has a circle of 25%. What's the probability that either Ben or Ava make a birdie? You could say 55%. Why would you say 55%? I said or, when I hear the word or, what does that mean? Add, okay, but you'd be wrong. I know, brutal. Okay, the reason why is because they can have what? They can have overlap. Right? They can have overlap. So we'll put Ava right here, we'll put Ben right here. This thing is supposed to be tracking me, it's not. It doesn't like me. It really doesn't like me. Oh well. I tried. So you got Ava, 30%, Ben, 25%, then you got the overlap. Okay, so how do we determine what that overlap is? That's called joint probability. How do we find the joint probability? What is it?
Probability. Probability.
Just the joint.
Oh.
How do I find just the joint? What is the joint probability? What is it?
Ava's.
Yeah. If they're independent, it's Ava's times Ben. What is 0.3 multiplied by 0.25? What is it?
0.075.
0.075. So that's how much overlap they have. So 0.3 plus 0.25 gives us 0.55, right? Minus 0.07, what is it?
0.075.
Minus 0.075. Okay, so if we're gonna do this, we've got 0.3 plus 0.25, 0.55 minus 0.075, which gives us, what does it give us? What is it?
Is it 0.55 minus 0.075?
Yep,
Or 0.475.
0.475. Okay, so the joint probability, there we go, you guys can't even see it, can you? I tried. 0.475. So the joint probability is the probability of Ben, or sorry, the probability of Ava plus the probability of Ben minus the joint probability of Ava and Ben. So 0.55 minus 0.075. Someone has a question? Yes. Okay. So if they are dependent, then I would say something in here. The joint probability or the probability of them both making it is 0.1. So I would just tell you right away, this, it already is. So if the joint probability is 0.1, then I would do 0.3 plus 0.25, which would be 0.55, minus 0.1, which would give you 0.45. Okay, so dependent, I would give you beforehand. So good question. Other questions? How are we feeling about this? Ish. Okay, I'm thinking I need to make this a little extra, like maybe put a link to the video on the joint probability. So that way we can dig a little bit deeper on that. And I'll make notes. Joint. Okay. Next. Okay. The next question that I have is if the probability of either Ben or Ava making it is 0.475, what's the probability that neither of them make it? 1 minus that, so 0.525, yes.
I just have a question. On the exam, when do you know when you're supposed to use joint probability?
If you see, and, that's going to be, a sign for you to use joint. Like what's the probability of this and this happening? that's gonna be joint. Also, if you see something that says or, and they can both happen together, then you're gonna have to do A plus B minus A and B. So in this case, it was Ava plus Ben minus Ava and Ben. Cool. Next question. Well, we did all that. So let's go to the next one. Word. Give me a different topic. Somebody give me anything that you guys enjoy about life. Nerf guns. And notice what I did here is I said, use the appropriate Excel formulas in the answer key. Thinking, thinking, thinking. So right here, I'm using the multiplication formula, permutation formula, combination formula to determine the number of possible outcomes, use NERP as a subject. Then frankly, not the easiest question to answer. But hopefully it will do something sooner rather than later. So multiplication. When do we use the multiplication formula? And yeah, there's X number of ways of doing one thing, Y number of ways of doing another thing. So X times Y gives you the number of ways to do both things, which I know some of y'all have your accounting stuff. So if you got your accounting thing, I'm not gonna hold that against you for not staying the whole time. Okay, so Nerf. Okay, there's 7 distinct models. Boom. There's 3 dark types. There are blaster shell colors, 5 colors. There are 6 targets. There are 10 volunteers. So choose 1 blaster, 1 dart type, 1 color. What is the total number of distinct loadouts? What is the probability that a cyclone loadout is chosen at random? Okay, so how many different ways or how many different blasters could you choose from? 7. How many different dart types? Okay, how many different colors? Okay, what should I use to find out how many different ways I can make a loadout there? Multiplication. Okay, it's gonna be 7 times 3, 21, times 5, 105. So there's 105 different ways that I could start this nerf pack. Okay, what's the probability that a specific loadout, so you choose the cyclone with any of the other things that you wanted? So here they want 1/7. So they're like, you can choose a cyclone, so there's 7 blasters. You choose a cyclone, and the other ones don't matter. But yeah, what's the probability of you choosing very specifically a cyclone with the elite neon green? That would be 1/105. So the probability of you choosing that very specific loadout, there's 105 different possible options. And that's the whole point of what we're doing. What's the probability of you choosing this one favorable outcome out of all the possible ones? So that's gonna be 1 out of 105. Okay. So choose an order of 3 distinct targets from 6. How many different ordered sets? What's the probability of a specific order? T2, T5, T1. So you've got to hit, there's 6 targets that you've got to hit, or there's 6 targets that you can hit, but you are choosing 3. Okay, and it matters what order you hit them. So what's the probability of you hitting this target, then this target, then this target? You guys track with me? So how do we do that? Permutation, because I'm picking a smaller number from a larger number. No tracking. A smaller number from a larger number. And order matters. So how do I do this in Excel? Yeah. Equals permute. Okay, 6, 3. So how many different ways are there to arrange 3 targets out of 6? 120. Okay, what's the probability of you hitting 3 very specific targets in that specific order? Target 5, target 3, then target 2. I'm hitting in this order. 5, 3, 2. What's the probability of you doing that? 0, 0. Or 1 out of 120, or 0.0, yeah. Okay, y'all tracking with me? Questions about this? Okay, so that's permutation. Next. Choose 4 refs from 10 players, or it doesn't matter how many teams. What's the probability that Alex and Smith, we're not gonna do this part. That Alex and Sam are on the same team, but choose 4 refs from 10. How do we do this? Combination. Okay, so how do I do combination? I go into Excel. I'm gonna go into Excel. Okay, equals. What do I do? So how many possible outcomes are there? 210 different teams that you can make of 4 out of 10. Okay. So should we move on to the next one? Okay. Next. Four. Sure. Who asked? Okay. Genevieve,
What?
one of you.
Yeah.
There we go. I was not close at all. Give me a topic. Coffee. There we go. Good. So there's 3 coffee types, 4 flavor syrups, 4 milk types, and toppings. Choose 2 toppings from 5. So right here, let's take a look. Okay, the number of ways you choose 2 toppings out of 5 options. What am I using here? Combination, why? Order does not matter. Okay, the number of ways to arrange 3 syrups in a tasting flight. Y'all know what that means? It's like 3 syrups in a row, and it matters. So what am I using there? Permutation. Okay, so let's do this. How many syrups are there? There are 4, so we're going to do 3 out of the 4. So let's come right here. Equals permute 4, 3. So there's 24 different ways that I can arrange 3 syrups out of 4 when order matters. Okay. And then if I wanted to look at combination with 2 out of 5. There we go, 2, or there's that, yeah. For permutation. Cool. Okay. Next. Let's look at. Sorry, I'm going quick because frankly, there's a lot to get through. And I'm trying to show you everything without going too deep. Okay. Uh. Discrete, uniform. Okay. Let's see. Use, what do you guys want me to use as an example? Coffee again, energy drinks, caffeinated beverages. Okay. So this one right here is something that you're gonna have to do. You're gonna have to look at this and be like, hey. Is it discrete? Is it continuous? What is it? So the number of cups of coffee each student drinks per day is reported for 100 students. Each student drinks an integer number of 0, 1, 2, 3, 4, 5 cups of coffee. What type of distribution should I probably use for this? How many y'all say discrete? Yeah, because you're gonna have the discrete numbers and then you're going to have the probabilities associated with each of those numbers. Okay. A coffee shop offers 5 espresso drinks, latte, mocha, americano, cappuccino, and a random customer is equally likely to order any one of them. Uniform. Now, is it the way that I would do uniform? No, because I told you guys in this class, I'm only using continuous data with uniform. This is still technically uniform, it's just not anything that I'm going to do in this class. Okay. And the thing there is everything's equally likely. If you see equally likely means uniforms. Okay, out of 10 energy drinks purchases, the probability that a customer will choose a sugar-free drink is 0.3. What's the probability that exactly 4 of them will choose a sugar-free drink? What should I use? What is it? Binomial, what gave it away? What is it? Sugar-free or not, so there's only 2 possible outcomes. What else? Exactly. So you see exactly this or less, or exactly this. Anything else that screams, hey, this is a binomial? There's one more thing. There is a set number of drives. Okay. Looking at the next one, the caffeine content in a 12-ounce cup of brewed coffee is approximately normally distributed with a mean of 120 milligrams and a standard deviation of 15 milligrams. Find the probability of a random cup has more than 135 milligrams of caffeine. What should I use? Standard normal probability distribution. What gave it away? It's got a standard deviation and it's normally distributed. You guys see how it's normally distributed? So if it's normally distributed, what can you use? The z-scores or the standard normal probability distribution. Okay, a soda machine dispenses drinks with the caffeine content measured in whole milligrams. The probabilities of each possible outcome are not equal, but sum to 1. So what is this? Discrete. This is very important, okay? Discrete probability distribution can have any values. They're all over the place. Okay. Now, the funny thing is this isn't actually discrete, but the way that it's set up to be discrete. Because it gives it in whole numbers and it has it all over the place. But technically milligrams is not discrete, it's continuous, but they use it as discrete. Once again, I wouldn't do that to you. Fair enough. Okay, so is chat perfect? No, we've already found 2 things that they did that I didn't like. Is it wrong? Yeah. But it's really close. Okay. Each brand of cold brew is a blind taste test. A, B, C, and D is equally likely to be selected by each participant. What is this? everything's equally likely. Uniform. Okay. Next. And check this out. Boom. Let's go on all that. We're good to go. Is this helpful? Is this going well-ish? How many of y'all think that going through it like this is good? How many of you guys prefer a normal quiz? Okay. Next. It's an experiment. What we're doing is an experiment. Out of 140 people, how many of you prefer a normal quiz? Okay, out of 140 people, roughly 40% like the normal quiz. 60% are okay with this. What's the probability if I ask another 180 people that 100 or less, or rather 100 or more, will prefer this style? What should I use? You guys want me to say that again?
Yes.
Okay. 40% prefer a normal quiz, 60% like what we're doing right now. Okay. If I were to ask another 180 people, what's the probability that 100 or more would like the ChatGPT style right now? What is it? Binomial. Two possible outcomes. Probability is the same at every trial. And then, yeah, we looked at the set number of outcomes. Okay. Give me a uniform probability distribution. Here we go. This is something that I know you guys have been struggling with-ish. Using lens. Okay, so at a coffee shop, the wait time in minutes for a customer's order is uniformly distributed between 2 to 10 minutes. The mean of any wait time between 2 to 10 minutes is equally likely. Okay, what's the probability that a customer waits less than 5 minutes? How do we do this? Yes. Okay, so what's the range? What is it? 8 minutes? Yeah, range is 8 minutes. Okay, so what's the probability of any one given outcome? If the range is 8 minutes, the total range is 8 minutes, what's the probability of any one given outcome? 12.5% or 1/8, right? Okay, so what's the probability that you will wait less than 5 minutes? What is it? 3/8? Yeah, so you have that smaller range, 5 minus 2, over the larger range, 10 minus 2, which gives you 3/8. Or 37.5, is that right? Okay. What's the probability that a customer will wait longer than 8 minutes? They messed up again. You see how they messed up again? It's 8 minus 2. Not supposed to say. It's supposed to say 10 minus 8. So 10 minus 8 over 10 minus 2. So that's going to be 2 over 8, which is 25.
It would be wrong if they're
Do it.
subtracting that.
Oh, you know what? I didn't see that. There you go. There's that. Just not the way I would do it. Okay. And then probability that a customer waited between 6 to 3 minutes. Just 3 over 8. Okay, how are we feeling about uniform? Better-ish? Okay. Uniform, and now let's do binomial. Word. Yeah, see what I wrote. We'll see what it does. Dr. Eide is conducting an exam review for 8 students. From previous experience, each student has a 20% chance of leaving the review early before it ends. Come on, it's a little funny. Is it a little funny? Okay. Okay, so what we're determining is the probability of a certain amount of people leaving early. What's the probability that no students leave early? How do we do this? So we have a total of how many students? 8. Okay. What's considered a success? Leaving early. Okay. What's the probability that they leave early?
Point two.
20%. Okay. And then they give you all these super cool things right here. Does this look really cool? But then I tell them to do this. Okay, so it gives you exactly how you need to fill it out. Okay, so what's the probability that no students leave early? We're going to go into Excel. Okay, equals binom dot dist. The number of successes. How many successes do I want? 0. How many trials do I have? Probability of success. And then true or false. Here it doesn't matter. But we'll just put false. So what's the probability that no students leave early if there's only 8 students? Yeah, 16.7%. Okay. So what's the probability that exactly 2 students leave early? What do I gotta change? So here, number of successes is now what? 2. So what's the probability that 2 students leave early? Yeah, 29%. Okay, what's the most likely outcome? How do I calculate the most likely outcome? What is it? Yes, it's going to be the probability multiplied by the number of trials. So equals 0.2 times 8. So 1.6. In other words, I've got to check for 1 and I've got to check for 6. So let's, or 1 and 2 equals binom dot dist. And we're going to do 2, 8, probability of success, 0.2, false, 0.29, and then let's do it for 1 as well. Which one's more probable? So this is for 2, this is for 1. Which one's more probable? 1. Is that a little weird? Y'all would think that you would round up, but don't round up. Check both of them rounded. So check if this is the most likely outcome, so this is the mean. But you need to check both 1 and 2. And so this is the probability of exactly 1. This is the probability of exactly 2. Questions about that? Comments? Okay. Let's do a normal probability distribution and then I will go over anything that you guys want. Yes.
Would you ask number 3 on the exam? So can
Probability that at most 2 students will leave early, so 2 or less students. Okay, yeah, the way that they phrased it is a little weird. Okay, and that last one is, like I said, the most likely outcome. And then bada bing, bada boom, let's go to Word. Okay. Okay, this is the last topic. Does anyone have a topic? Legos? A Lego factory. What is the z-score for a Lego brick that weighs 2.65 grams? What is the probability that a Lego brick will weigh less than 2.65 grams? What is the z-score for a Lego brick weighing 2.35 grams? So on and so forth. Okay, so what we need, what are the things that we need? What's the formula? Do you guys know what the formula is? Z equals, what does Z equal? X minus the mean in parentheses divided by the. Okay, so let's do that. Okay, so X is the weight of a single Lego brick. So we're gonna come right in here. And we're gonna do the mean is 2.5, standard deviation is 0.1. And then we're going to scroll down. And we've got a z-score, or sorry, we've got 2.65. So what's the z-score? We've got equals, what is it? Hold on. 2.65 minus the mean divided by what? Standard deviation. So what's the z-score?
say
1.5 standard deviations above the mean. What's the probability of having a Lego brick that weighs less than this? How do I calculate that? Norm.s.dist equals norm.s.dist. So what's the probability of having a Lego brick that weighs less than this? No, just, yeah, 93%. Okay, 93.319%. Okay. So what's the probability of having a Lego brick that weighs less than this? What's the probability of having a Lego brick that weighs more than this?
1
Yeah, 1 minus that. Yeah. So what about a Lego brick that weighs 2.35? Check this out, you guys ready? All we gotta do is change this. 2.35. And then 2.4. Okay, so the probability of weighing less than this is now 6.6%. The probability of weighing less than this is about 15%. Okay. So Oh. Yes, yes, I can do that. What is the probability of getting a Lego brick that is between those two values? Okay, are you ready? It's really not that bad. So these are the weights of the Lego bricks. Okay, so what's the probability of getting a Lego brick that is between these two weights? What we're gonna do is equals this minus this. So what we have here is what's the probability of weighing less than this is 93%. What's the probability of weighing less than this is 6.6%. What's the probability of being between these two? You just take the probability of being less than the one and subtract the probability of being less than the other. And the reason why is, gosh, I wish. Yeah, that's horrible. Okay, the probability of being less than the 2.65. Okay, and then what was the other one? 2.35? Is what, 6%? And then this was 93%. Okay, so what we do is 93% minus 6% gives you the probability of being between the two. Y'all tracking? That help? Okay. Other questions? Anything else? I just forgot what number it was. I was trying to remember it. I just remember, so 6.6. That's really the long and short of it. Yeah. Okay, other questions? Something that you guys want me to go over? You guys want me to go over the joint conditional probability stuff? Okay, let's do that. Yeah.
What do you know about this?
So, if it's skewed, you can't calculate anything. That's pretty much all you got. Okay. At least not right now. Good. So, .gam. So, y'all give me a topic. Any topic.
Andy.
Candy. Okay. So, what is the probability that you are going to, you got two events, probability of A and the probability of B. Okay, so I might ask a question, such as, what's the probability of you grabbing I don't know, a candy that has chocolate? Okay. And a candy that has, what's something else that you guys like in candy besides chocolate? Mint? Mint? Okay. These are your only two options. Okay. So we've got, let's do a few things. The probability that you will grab a candy that has chocolate, let's say, is 45%. The probability that you will grab a candy that has mint is 30%. And I'm just not accounting for everyone else because everyone else is not grabbing one of those. Okay, so chocolate, we'll put that at 45%. And then mint, we'll put that at 30%. And we will say the probability of it having chocolate and mint is 12.5%. Okay, so what is the probability that you grab a candy that only has chocolate? What is it? Nope. What is it? Not 37 and a half. 32.5. Okay. And what's the probability that you are going to grab one that only has mint? In other words, you're having just a mint. 17.5%. Okay. And what's the probability that you didn't get either one of these candies? What was that? Oh, what's the probability that, oh, let's back up. What's the probability that you got either chocolate or mint? So what we do is A, okay, so we've got the probability of A plus the probability of B minus the probability of A and B. So what is the probability of A? 45%. What's the probability of B? 30%. Minus what? What is it? 12 and a half. Which equals what? 62.5. Okay. So 62.5 is the probability of chocolate or mint. What's the probability of having neither? What is it? Yeah. 1 minus 0.625. And what does that equal? 0.375? Yes. Oh, you were just playing with your pencil. Yeah. Okay. So 0.375 is the probability of neither. Okay. How are we feeling about this? Better? Lindsay, how are we feeling? Okay, so that's a great question, Lindsay. If I don't give you the probability of them both, then I'm assuming that they're independent. And in order to get the probability of them both, what do you have to do? Yeah, what's 45 multiplied by 30%? 13.5? Okay. So yeah, if I don't give it to you, then you've got to multiply the two of them together. Cool? Other questions? Yes, correct, because I assigned it. Right, so that's what she was asking. Are you always going to give it to us? Sometimes I will, sometimes I won't. But if I give it to you, then these right here are not considered independent. The chocolate and the mint are not independent. In other words, this is not going to be perfectly that joint probability of that are independent of each other. So, yeah, does that help? Okay. Next. Who's got a question? Yeah, go ahead. Not a dumb question, go ahead. Because, there's gonna be there's gonna be people that don't eat either. Is that what you're asking?
Probably the third format, but that's both.
Right, so if I give everyone in here the opportunity to grab pieces of candy, is everyone gonna grab a piece of candy? Well, so if I just dump a bunch of candy, how many of y'all wouldn't grab any candy if I dumped it on the front? How many of y'all would? Okay, how many of y'all would not? So, you tracking? But I hear what you're saying, like, there's candy. You gotta have the candy. You just wait until after Halloween when my kids get way too much candy and I'll bring it to class and y'all will be like, we've already had enough. Okay. Uh, yes. No, go right ahead.
So to get the 32.5, you do the 45 minus 12.5, but can you explain why?
$35 month.
You do the 45% minus 12.5 to get the 32.5.
Yes.
Explain why.
Okay, this right here, 45% is this whole circle. Okay, 12.5 also has mint in it. So what percent of individuals have chocolate but not mint? To be honest, I'm not gonna ask anything that specific. So the most specific, it's probably gonna be 45, 12.5, 62.5 are gonna be the ones that you care about. Okay. So this is just like one step further than what I normally do. Okay. Next, I'm just gonna do one more. Okay, you guys ready? Yes. Yeah, go right ahead. Tell me what the shoes question was.
There's a big part. Number of shoes, then the range, and then there's a midpoint and the probability.
I have a hold up screen problem.
Okay, so give me the numbers. The midpoints, give me the midpoints. Okay. So what's the percent for two? 5, 8, 11,
0.2407. 0.1944. 0.1111. And 0.0556.
okay. So to be frank, I'm not gonna solve it. But I'm gonna show you how to. Is that fair enough? Good. If you guys look at your formula sheet, what you're going to see is something like n, probability of n, okay, and then n multiplied by probability of n, and then we have all of those numbers right here. And then when you add all of these numbers together, so sum, when you sum all these numbers together, it gives you what? Not 1. It gives you the mean. So these values multiplied by the probability, you put them all in right here. you add them all up together and it gives you the mean. Okay, then after that, we're going to come right back here and it's going to be n minus the mean. And you do that all the way down. And then after that, you do n minus the mean squared. Do it all the way down. And then after that, you do the probability of n multiplied by n minus the mean squared all the way down. And then when you add all these together, what does it give you? It gives you the variance. And then in order to get the standard deviation, what do? Yep. Okay. So it is this long, drawn out, pain in the butt process that really should only be done in Excel. Because you can copy, paste, drag, drop, do all sorts of fun jazz. Would you guys agree that this looks like a long, drawn out, pain in the butt process? Okay. You will at max have one question. You will have one question on your exam with this. On your formula sheet, does it bring you through step by step exactly how to do this? Practice that. Okay. So the mean and then the standard deviation, those are the two hardest things to find. Okay. Other questions? Okay. So do you guys want me to go through one more, or you guys want me to be done? You guys want me to be done?
I would say maybe go over one that you would say would be most likely to be on the exam outside of that one.
Did you go over discretes?
The discrete one more time? This? This is discrete, yes. Yes. Okay. I will do one more that is like what you guys see on the exam. Okay, you guys ready?